Watch this structure. When you attach a rigid, highly specific data schema directly to a fast-moving business problem, it breaks. In the enterprise environment, application lifecycles are misaligned with database lifecycles. This diagram illustrates the problem. When business requirements mutate and pull in new directions, that tight coupling places stress on the underlying data structure until it fails. Roughly 80% of an application's total cost is consumed by post-deployment maintenance and structural patching. This financial drain occurs when databases are treated as temporary process followers rather than permanent architectural assets. The root cause of this brittleness is a widespread misapplication of the architectural principle form follows function. IT professionals often assume the function is today's specific business process workflow, forcing the database schema to perfectly mimic that immediate workflow. Sustainable data architecture requires the data to be decoupled from the business process. The inherent properties of the data object itself must dictate the architecture, regardless of how that data is used in a specific instance. Architectural longevity comes from modeling the permanent business object rather than the transient business workflow. Take a look at this physical brick. Its inherent physical characteristics, its density, dimensions, and material define what it is. Because of that specific form, it functions as a structural unit in a wall. However, those exact same inherent characteristics make it a poor tool for pounding in a nail. Translating this physical analogy into data logic, the brick is a business entity, like a customer, with physical dimensions becoming inherent data attributes, ID, name, and location. By defining these isolated characteristics, the customer entity plugs into dozens of different application workflows. Business processes change rapidly, but underlying data structures and entities remain relatively constant. Extracting the data's design from the business process creates a reusable structural asset, preventing future rebuilds. Scaling this logic up to the entire corporation gives us the enterprise data model, the highest level of architectural abstraction in an organization. This model serves as a common pattern language for the business, standardizing how entities interact. Operating at this macro level insulates core data assets from shifting operational priorities and new software trends. Enforcing this discipline across decentralized corporate departments is a significant challenge. Without a central hub, the environment devolves into a chaotic web of sporadic connections. The Zachman framework is a management tool designed to wrangle this scale of complexity. Without a rigorous enterprise-wide framework, localized data structures will eventually become disconnected, unmaintainable silos. This is the Zachman framework, a rigid ontological matrix. It separates the what, data, in column 1, from the how, function, in column 2. Column 1 governs data form independently. Column 2 dictates processes, which can be replaced without altering column 1's definitions. The grid structure requires enterprise architects to define data form separately from process function, removing fragile dependencies by design. This reveals the law of perspectives. The definition of data changes depending on which organizational row you are looking at. From the business owner's perspective in row 2, data is conceptualized as high-level business entities and their relationships. For the systems designer, those broad concepts must be translated into a logical data model that respects normalization and relational integrity. In the builder's perspective, the logical model is hardened into physical tables, segments, and keys. This brings us to Zachman's completeness rule. An enterprise architecture is considered finished when every single cell is populated with its required artifact. Populating every cell removes translation ambiguity, ensuring business intent directly dictates physical structure. Look at this foundation grid. A rigorous architecture provides foundational stability, allowing developers to build on top of a predictable, standardized base. A properly architected enterprise data model acts as a bedrock layer that is insulated from the frantic pace of the application layer above it. Here is that data architecture represented as a static horizontal plane. This decoupling allows UI layers, microservices, and workflows to be upgraded without risking data corruption or requiring database migrations. This creates a living framework, a system that evolves with business needs rather than resisting them. True architecture absorbs systemic shock and market changes, while tightly coupled systems tend to break under pressure. This defines the mandate of the modern enterprise data architect. Architects prioritize the long-term integrity of the data, over the immediate speed of a single software release cycle. Watch how the hardware ages in this time lapse. This approach builds information stores that outlive the specific applications and processes that initially populated them. Respecting the form of data as a permanent, standalone asset ensures the enterprise's intellectual capital remains accessible and intact as business needs evolve.